Hello friends, I welcome you to my channel Biotech Medicine. Today's video is on log concept for virus removal. Log removal or log reduction system is a universally accepted scale for expressing the efficacy of the disinfection or sterilization. So it's not a physical unit for checking the purity of any sample. It is also not a method for purifying the water sample, but it is a method for quantifying the efficiency of a process for pathogen inactivation. Let's discuss it in detail. In wastewater, there are many bacteria and viruses. There may be billions of bacteria and millions of viruses per liter of wastewater. So when this huge number of microorganisms are there, then they have to be removed. And the pathogen removal is measured in terms of log reduction. In principle, this concept is true for all the microorganisms, for helminths, bacteria, protozoa, even for viruses. But in practice, it is not always uniformly applied to every microbe everywhere. So then it is mostly used for viruses. Universally, this is used for the viruses, this log removal system. And for the other microorganism, most of the time there are many different type of tests. One test is presence and absence test. That means either that particular microorganism is present or it is absent. Or there may be the indicator organism test also. Here, we do not test for each and every pathogen which may be present in the sample, but we just take the indicator organism and we test for that indicator organism. For example, E. coli, Enterococci, Clostridium, etc. Now, how we define it? Log system doesn't measure purity directly, but it measures how much contamination is reduced. So if there is a contamination of bacteria or viruses, then how much it is reduced. That is what the log system is. In other words, you can say log scale is an expression how efficiently the viruses are reduced in a particular sample. And the log reduction targets are used as safety standards for water supply, because water supply is most of the time used for human beings. So that's why safety standards are very important here. So these log reduction targets are used as safety standards. And overall, it is not a physical unit, but it's a mathematical way to describe how well a process removes or inactivates the pathogen or the microorganisms. Now, let's see, this log reduction terms are used where? So, it can be used in water treatment or wastewater treatment units. There may be the drinking water safety rules and regulations, and we have to follow the log system, like 4 log should be there for the drinking water. Similarly, the wastewater reuse standards are also fixed, and accordingly, for which application we are using this wastewater after the treatment, accordingly the log scale is there, and then the membrane and filtration performance also, the log reduction systems are there or log reduction terms are used. So another important industry where this term is used is food industry. And in food industry, because there are many pathogens, they have to be inactivated by different methods. The methods may be thermal as well as non-thermal. So there, how many pathogens have been killed or they have been removed, for that we use the log reduction terms. Similarly, for thermal kill steps like the sterilization, pasteurization, where we kill the pathogens by raising the temperature. So one such example is the example of juice industry, where the salmonella problem is there. So here the standard set is for 5 log. So you have to stick to that. And the third one, again, which is very important, is the medical and healthcare. Here, the 6 log reduction goal is set for the sterilization of the equipments. So mostly it is this water reduction terms are used in water treatment, food industry, and medical and healthcare. There are various levels for the log reduction. So this table is showing the different levels from 1 log to 6 log. The levels can be even more than that also. But the initial point or the first log level is the 1 log. And if we say 1 log, that means it is 90% removal or reduction has taken place. And it can also be said that 10x reduction has taken place, or 10x, also you can say 10-fold, or you can say 10 to the power 1 reduction has taken place. And if I try to give you an example, suppose there is a sample and which has got the 1000 viruses per liter. This unit can also be changed, and 1000 can also be changed, because in real world the samples have more viruses than just 1000. I'm giving you this example just to simplify the things. So if 1000 viruses are there, so after the reduction of 1 log, it will be 100 viruses. So from 1000, 100 viruses now. So the reduction has taken place 10-fold. When we say 2 log, in percentage it is 99% reduction has taken place, or 100x reduction has taken place, 100-fold reduction has taken place. So that means if initially there were 1000 viruses, now how many are remaining? 10 are remaining. So just to calculate, you can cut 2 because it is 100-fold. So you can just cut 2 zeros. So that's how 10 are still there. For 3 log, 99.9%, and it is known as 1000x reduction. Here you can say that out of 1000 viruses, 1 is still left. And similarly, you can go for the 4 log, 5 log, and 6 log. In 4, 5, and 6 log, you see that 0.1 virus is left, or 0.01 virus is left, or 0.001 virus is left. So it may raise a question how this is possible, how 0.1 virus can be there. So virus is whole unit, so there should be at least 1 virus. So 0.1 means 1 virus in 10 such samples. 0.01 means 1 virus in 100 such samples, and 0.001 means 1 virus in 1000 such samples. So that's what this whole thing is. So now there can be higher log targets as well. They are not up to 6 log only. There can be higher ones also. And scientifically 10 log and 12 log, or even higher reductions up to 15 log are also possible. When we go towards the higher side or higher log, that means higher safety. If we go towards the 10 log or 12 log, that means this type of sample is very, very safe. Mostly the pharmaceutical industries, which are very sensitive industries, so they may go up to 10 log or 12 log, and space food processing follows generally 12 log reduction, because when the travelers they go to the space, they take food with them, and for that food processing lots of precautions are taken, because in space you don't have any doctor, you can't afford any kind of contamination. So that's why up to 12 log reduction is used. There are various regulatory frameworks already set up. So there were many regulatory frameworks earlier also, but the new regulatory frameworks use the log removal levels to set any target. The required level varies depending on the risk, because what is the type of use, what is the regulatory standard. So according to that, it may vary. These standards also vary from country to country, and also sometimes from one region to another within the country. And for example, for the potable water is the water which is used for the drinking purposes. So usually 4 log virus reduction requirement is there. So this is kind of universal regulation. Recycle wastewater. WHO guidelines say that 2 log to 6 log should be there, depending upon the use, depending upon the application. And decentralized wastewater system means which is small scale and not centralized. So here the 2 log is minimum as per the new policies. In USA, if you see, the EPA guidelines say that all the surface water and the groundwater which comes in contact with the human beings, that must provide 4 log inactivation of virus. So at least 4 log should be there. And in Canada also, same, municipal scale drinking water, minimum 4 log removal is recommended. And in British Columbia province, which is a part of Canada, there 43210 scale is used. So what is that? It is 4 log virus. So as far as the virus contamination removal is concerned, 4 log should be there. Then 3 log for the protozoans. 2 forms of treatment. This is not 2 log. Okay. So this is 2 forms of treatment because many type of treatments, many methods are used. So at least 2 should be there. 1 NTU turbidity. NTU is the unit for the turbidity. So 1 NTU should be there as far as the turbidity is concerned. And 0 E. coli. E. coli is a indicator bacteria which should be absent in the sample. So that is what followed in British Columbia. And as far as India is concerned, we follow the universal standards. And there are permissible limits already set for the microbiological parameters. However, there is no single mandatory national standard for viruses, this log system. So mostly, international benchmarks are followed. Now let's see the applications. This 2 log is used for landscaping, toilet flushing, gardening, cooling towers, even for the construction of the buildings. So for all these purposes, if you are using the water, then the 2 log is okay. Because here we are not, this water is not coming directly in contact with the human beings. Then 3 log is generally for the small household scale, for the recreational water, for making the, the small lakes for the recreation or fountains, or it can be used for the irrigation but for non-edible crops. But 4 log is for the potable purposes and also for the sensitive industrial applications, for example food industries or the cosmetic industry, because that is also for human beings. And then 5 to 6 log for healthcare and clinical use, and also for the food processing. Here we use the higher one, 5 to 6 log. And 10 log for pharmaceutical industry, that we have already discussed because these are very sensitive industries where the extra care is needed. And 12 log for the space travel. This also we have discussed. So according to different type of application, the standards are also different. So it may start from 2 log, but it may go up to the 12 log. Now, 2 log system is very common. Mostly it is used in all wastewater industry. So why it is so common? Because 99% removal has already taken place. So 99% removal is quite good for many of the application. I'm not saying for each and everything, but for many of the application it is quite good. And 2 log reduction is commonly, why it is common, why it is mentioned commonly, because it is minimum practical benchmark for many real world systems. So in many real world systems, in many examples, you will see that at least 2 log reduction is needed. And if initial contamination is already very low, if in the sample very little amount of viruses are there, then 2 log can be quite sufficient. but if it is, the concentration is very high, then it may not be sufficient. And mostly used in water and wastewater treatment, in wastewater treatment units. This 2-log system is very common, and also it is very cost effective because here we are using just 2-log. So not many methods are used here for 2-log. So for many real world application, you have to be cost effective also. So as you go towards higher side, cost will also increase. So this is cost effective. So that is also one of the reasons that it is very common. Now, how this reduction or log reduction is achieved? Log system is achieved by combining different treatment and disinfection steps that kill the microorganisms gradually. So that means here we do not use just one method for removal, but we use many of these methods, and that's how one after the other different methods are used, and gradually the microorganisms are killed. And multiple barriers may be like sedimentation, filtration, membranes, UV, disinfection. So many of these or any combination can be used for reduction. And of course, each of the step reduces the pathogen by a certain log. Suppose we use the sedimentation first, so it will reduce to a certain extent. Then we use the filtration. So again, it will reduce the viruses to a certain extent or to certain log. And then afterwards, maybe we use the UV. So ultimately, the resultant would be what is actually required. So suppose 4 log is required. So for 4 log, achieving the 4 log, it's not necessary that we just use one method. We can use many methods, and gradually it will remove the viruses, and ultimately the cumulative effect will be what is actually required. Now these are the methods used for different log scales. 1 log, which is mostly not used. So this is very low grade treatment. For example, the screens or primary sedimentation can be used. For 1 to 2 log, filtration or biological treatment, these can be the methods. And here we use the sand filter or rapid filter, activated sludges, trickling filters. So these are the examples here. For 2 to 3 log, as we go towards the higher side, enhanced filtration or UV, chlorine. So these can be the methods. And dual media filtration and the UV disinfection, chlorination, these are the examples. When we go for 3 to 4 log, then membranes, different type of membranes can be used, and advanced disinfection is the method. And here the examples are, membrane bioreactors we use, then ultrafiltration can be used, ozone can be used, UV plus chlorine, that kind of treatment can be done. For 4 to 6 log, we stick to RO. RO is reverse osmosis and advanced oxidation. Examples are RO or nanofiltration or ozone AOPs, advanced oxidation process, or UV AOP. So that combination can be used. 6 to 8 log, it's quite high. So here the high grade purification is needed, and pharmaceutical water, dialysis system, multi-barrier hospital water. These are the examples. And for the highest level, 8 to 12 log, you need sterilization. And the examples are autoclave, high dose radiation, space biosafety standards, high level sterilization. So these are different type of methods which we use for different log levels. Now, why this log system matters? Why we should use it? See, first thing is that this is scientific way to measure the pathogen removal. So if anything which is scientific and which is universally accepted, then that is considered good. So that is the first thing. Then it helps decide safe water reuse levels. So because we have already seen there are different levels. So if the log system is there, then it decides, suppose 2 log, 4 log, 8 log, whatever. So it decides safe water reuse level. So how you can reuse it, or what can be the application? It protects public health, of course, and it is also required by WHO, EPA, and CPCB. Many times, if some regulations are there, then you have to stick to those regulations. So that is also why this log system is important these days. And in this log system, there is multiple barrier system. You are not just using one method, but you are using many methods step by step. So that is also something which is important here. Now, let's see how we conclude it. Log reduction is a scientific measure, as we have already discussed, how effectively pathogens are removed from the water. So, if the pathogens or the microorganisms or viruses are present, how effectively they are removed, that is the log reduction. And it is not just a mathematical calculation, but it is a framework for the public health protection. It is a layered protection, one after the other method you are using. So it is to ensure the safe and smart water reuse. And higher log reduction means higher safety. It helps us to reuse water safely and protect environment and support public health. So that is all about the log system. I'm also uploading another video which is basically on the 2 log system, because that is the one which is most commonly used. So please go through that video also. And thank you for watching this. And if you like it, please subscribe the channel.